Okay, so for the problem of the resistive medium, we have seen these are the expressions which we are getting where A is some fixed constant, which we can see easily from the expression. It is not of importance here, so I have just written A and as expression y in terms of t, expression y dot in terms of t, similarly that for x and x dot. Now you can see, or rather we want to observe what will happen if I want to carry on infinitely. That means if the time range for which the motion I am carrying on is for infinite time, what will happen? As you can see, if t tends to infinity, then obviously we know e to the power minus kt will tends to 0. So that means from here you can see what will happen. First, let me focus on the y dot. Y dot will go into this part becomes 0, RHS becomes 0. So y dot is g by k minus g by k. Right, that means something constant. What about x dot? X dot vanishes. X dot equals to 0. Okay, so what is the implication of it in our motion? So you see from here, I have started from here, or rather I have projected the particle with some velocity u. So it has started rising, okay, first because of this projection velocity. And as it is rising, two external forces are acting. Both are resisting the motion. One is G and one is this resistive force as mkv. Okay, so what will happen? The velocity, first you have projected some velocity, it will decrease with time. And as soon as it reaches the maximum height, here dy dt vanishes. Then what happens? After that, as it is traversing downward, dy dt is less than 0. So in this portion, dy dt was greater than 0. And in this portion, dy dt is less than 0. So dy dt goes on decreasing. So what does that mean? My y increasing direction is this one. Okay, y increasing direction, but I'm moving in opposite direction. So dy dt is less than 0. So here also I am getting the same thing from the calculations. This is from the figure I am saying. And from the calculation also I am getting the same thing. Now the thing is, how long will it continue? I can see this x part, dx dt part will vanish. 0, it becomes 0. But the dy dt part goes on decreasing. Okay, that means what happens? Actually my car is having an asymptote here. This line is nothing but minus g by k. Okay, so this is becoming an asymptote, and as we know what is by the nature of the asymptote, asymptote is nothing but a tangent to the curve at infinity. That means if I can continue up to infinity, then if I can reach infinity, suppose I can reach, then this curve will touch this line. Okay, so that is what is happening here. When t is going on increasing infinitely, my dy dt is going on decreasing, becomes negative, more negative, and so as we can see from here, it is going towards, or rather approaching towards this line minus g by k. So it is having an asymptote parallel to the y-axis in this case. Okay, and what happens to my y? Y also goes on decreasing. As you can see from the figure also, so y also goes on decreasing, because if you put t tends to infinity here, this part again vanishes. So gt plus ky equals to a is a positive constant. You may check from the solution last we have done. So gt plus ky equal to something positive. So y is equals to this positive minus g. Oh, what happens to, let me just simplify it. When t tends to infinity, this portion tends to infinity. So ky tends to minus infinity. Ky tends to minus infinity because this is tending towards infinity. So ky equals to minus gt you are writing from here, and then if t tends to infinity, then ky tends to minus infinity. We can also check it or cross check from the figure. This is indeed happening. You can see you are not stopping. You are going on decreasing your y, or rather you can say you are going on increasing y in a negative direction. Okay, so this is also what is coming from the calculation, but x is fixed. Okay, x is fixed from here, and you can see if this t tends to infinity, then x ultimately stops at u cos alpha, and x dot vanishes if t tends to infinity. So this is the figure, or rather the physical implication which comes if I want to continue my time for my motion for infinitely large range of time. So this is what they have calculated here. Okay. And from here also, like the last one, when there was only gravity, you can easily calculate the greatest height by putting the condition dy dt equals to 0, because dy dt is just vanishes momentarily at the point when the particle reaches the maximum height. And from as we have already calculated dy dt expression, you can easily plug it in here, dy dt equal to 0 expression, and you can just simplify the other to find out at what time it will attain the greatest height. Okay, let us stop here.